Today with Eric, we're going to be talking about the musical seismograph, which is part of the project for the Advanced Seismic Warning System. And so the musical seismograph is basically the part of the system which is the output of it, and how you receive it is going to be through musical tones.
Yeah, I'll get into all the details, because the seismic signals are far from audible because the frequencies are so low that they have to be converted into audio tones. So that will be how they become musical, and I'll get into the whole engineering idea and how to amplify the signals and how to transmit them. So this will be kind of like it's the Bell system approach is going to be used the whole way, which in today's mentality is a completely foreign or alien way of doing things, which to a lot of people would seem not to make sense, but at any rate, that's the way that I operate, and that's the way we're building all of this stuff. So it'll be quite interesting to people who have never been familiar with this type of engineering before, which is based more on electrical rather than electronic concepts. And also, because the musical scale is being used as the frequency band, all kinds of the interesting properties involved with the musical scale will also be presented. And this musical scale will not be the one that's in present use, what will be the original musical scale, and we'll get into a little of that too. And then, if time permits, we'll go into the mine and connect to the seismic sensors and see what we can get out of them. This experiment hasn't been done yet. I just finished the Tesla converter to convert the seismic waves and the audio waves. So all this is going to be demonstrated a step at a time. We start with C to C. This is our bandwidth, or our band, our frequency band, just like the AM radio band, and it has its channels. So now, if I split this octave at A, then we have what's called a musical chord, or that is one characteristic musical sound, and we can propagate through that. Any combination of those tones. Now, in this case, for our experiments today is A of 426 2/3, and somehow amplitude modulate this signal onto the carrier, and then they get the composite output that will go through the voice frequency amplifier and then go through many stages of amplification without baseline wandering problems and other types of instabilities inherent with direct coupled amplifiers. This happens to be a process that's almost impossible to achieve electronically, and so we have to invent and go back to Nikola Tesla and find out how he would deal with such a problem.